In this video, we're going to go through a few examples about solving rational equations. Okay, so one thing that's different about solving rational equations versus other equations, so you just need to be extra careful and vigilant. Same goes with other equations though. You should always make sure that your solution is in the domain. Okay, so why extra vigilant when it comes to rational equations? Well, because rational equations always have, well, not always, but most of the time they have a number that they're not allowed to equal. Okay, so in this case, so the domains are restricted. They're not negative infinity to infinity. So in this case, we see, x is in the bottom of all three fractions. So, clearly x can't equal 0. X cannot equal 0. If x were to equal 0, then we would have, undefined parts of this fraction here, and so you wouldn't have real numbers on both sides of the equation. So that'd be a problem. So when you're going through and you're solving, if you get your answer and it says x equals 0, that's not a valid solution. So what's that called? That's called an extraneous solution or an extraneous root. So let's go ahead and solve this one, see what happens. First thing I always like to do is move everything over to the same side of the equation. So I'm going to go ahead and do that so I'm going to subtract 1 over 2x. Oops. And then I'm also going to subtract 7 over 6x squared equals 0. Okay, so I need to get the same thing on the bottom of all three fractions so that I combine what's on top. So this one has 6x squared, this has 6x squared, so those two are good. I need a 6 and a x squared on the bottom of this one. So what I'm going to do is I'm going to multiply this one by 3x and 3x. So on the top and the bottom, I'm going to have 3x there. So 3x over 3x is 1, so I'm not changing anything about it. Okay, so I'll have 1 over 6x squared minus 3x all over 6x squared, right? Because 3x times 2x is 6x squared, minus 7 over 6x squared equals 0. Okay, so now I can combine what's on the top of the fractions. Alright, and I end up with this over 6x squared. Okay, so now if the top part of this fraction is 0, then the whole thing is 0, right? So I can just set the top part of this fraction to equal 0. Alright, if the bottom half is 0, well, then it's, not in the domain. It's an unreal number. It's undefined. Okay, so let's go ahead and solve just the top part equaling 0. So I'm going to go ahead and combine like terms. So I have 1 minus 7, which is negative 6. Alright, then I'm going to add 6 to both sides. I'll have 6 equals negative 3x. And then I'll divide both sides by negative 3, and I'll get x equals negative 2. Okay, and negative 2 is in the domain, right? Because the domain is everything except 0. So it's in the domain, so there you go. There's your solution, negative 2. Okay, so now let's do another example. So let's see. First thing I like to start with is by thinking about what's in your domain, and then once we have the domain, we know that those are going to be values that we need to think about. If our solution comes out to be one of those values that aren't in the domain, then we're going to have a problem. Okay, so if we look here at this first term, x minus 3, it's on the bottom. The bottom of fraction can't be 0, so we know that x cannot equal 3, right? Because if x were to equal 3, then 3 minus 3 is 0, and that'd be that'd be a problem, undefined. All right, and then if x equaled negative 3, same situation for this fraction there. So x cannot equal negative 3. Okay, and then lastly for this side, over here on the right-hand side, x squared minus 9. So that would basically be 3 or negative 3, right? Because 3 squared minus 9 is 0. Negative 3 squared minus 9 is also 0. So both those are already taken care of. So in the domain, your answers cannot be 3 or negative 3. Alright, so let's go ahead and solve this. So first thing I'm going to do is bring the 6x divided by x squared minus 9 over to the left-hand side. So I'll have everything on one side of the equation. Okay, so I'm leaving lots of room because I'm going to have to do something to make the bottom of the fractions all the same. Okay, now remember that, x squared minus 9, this is the same thing as x squared minus 3 squared. So this is the same thing as x minus 3 times x plus 3. Okay, so whenever you have x squared minus some term that's squared, it always breaks out like this. X plus that term, x minus that term. Okay, so if you don't believe it, FOIL this out, double check that this is true. We're going to use this fact though because over here, I want the bottom of the fractions to all be this 9. Oops, didn't mean to erase that. I want the bottom of the fractions to all be this x squared minus 9. Okay, so I want the bottom of the fractions to all be this x squared minus 9. So, I need to multiply this x minus 3 by x plus 3, and then I'll end up with having x squared minus 9, right? So if I do it to the bottom, I must also do it to the top, so that way this is basically the same thing as multiplying it by 1. Okay, then this term here, x plus 3, needs to be multiplied by x minus 3. Okay, alright, so now I can write this as x times x plus 3, okay, all that over x squared minus 9, right? This term here is x minus 3 times x plus 3 is x squared minus 9. Okay, so that minus 3 times x minus 3 all over x squared minus 9 minus 6 over x squared minus 9 equals 0. So now I can combine all the terms that are up top. Oops, that should be 6x. Okay, so now I can combine all the terms that are up top. So this is x times x, which is x squared, and then x times 3, which is 3x, sorry. Plus 3x minus, so negative 3 times x is negative 3x, and then negative 3 times positive, let's say this. So negative 3 times negative 3 is positive 9. So that's positive 9 minus 6x. All that over x squared minus 9. Okay, so we know x cannot equal 3, and, the bottom, would equal 0 would mean undefined, so we really only have to focus on what's happening up top here. So I'm just going to rewrite the top. Now these two terms cancel, and so then I'll have plus 9 minus 6x equals 0. So I'm only going to rewrite the top because the bottom, like I said, if it's 0, then it's undefined. Okay, so let's see. And now let me just rearrange this to make it into standard form. Okay, so plus 9 equals 0. Okay, so now let's see. Is this factorable? Okay, so I'm going to write x on both here. Now, what times what is 3? What times what is positive 9, though then if you were to add them together, you get negative 6. So what times what is positive 9, but if you were to add them together, you get negative 6. Well, negative 3 and negative 3, okay? If you were to, FOIL this out, you should get this equation here, okay? So if you were to FOIL this out, you get this. So these two things are the same. So now all you have to do is set this equal to 0, x minus 3 equal to 0, and no need to do it again because, if this one equals 0 or that one equals 0, if this part equals 0 or that part equals 0, then the whole thing goes to 0, but they're the same thing, right? So really just x minus 3 equals 0. That's all I have to worry about. So add 3 to both sides, I get x equal to 3. Oh, that is not in the domain. Okay, so I got a solution, but it's not in the domain. This is why I said it's so important that you check that whatever solution you get is in the domain. So this is not in the domain. So you say no solution. Okay, so no solution, or you could say that the null set is your solution. So no solution to this equation.